to create logic gates, and then combine logic gates to achieve more complex behaviors, with inputs and outputs typically flowing in the same direction, meaning signals move forward. But when discussing memory, we're referring to the ability to retain information. So we might instinctively think about what occurs when we take an output and connect it back to the input of the circuit. Let's examine the behavior of an OR gate in this situation. We establish a default state where everything is off. Remember, the output of an OR gate is 0 if and only if both inputs are 0. When we set the first input of the gate to 1, the output changes accordingly, and for a brief moment, measured in nanoseconds, the circuit looks like this. But because electricity moves extremely quickly, this output value propagates back to the input almost instantly, changing the second input to 1. And now, with the second input of the OR gate set to 1, the output remains 1 regardless of the value we set for the first input, as long as the transistors are powered, of course. So, in other words, this circuit is remembering that the output was set to 1 at some point. With the AND gate, we can get something similar. Recall that an AND gate outputs 1 only when both inputs are 1. If we start from this state, and then change the first input to 0, the output will become 0. Again, for a brief duration, the circuit resembles this configuration, but the output immediately propagates back to the second input. Now, with one of its inputs permanently set to 0, the gate will consistently output 0, regardless of the value we set in the other input. Thus, in a sense, we could say, the circuit remembers that its output value was set to 0. Now we have two circuits, one capable of remembering a 0 and the other capable of remembering a 1. However, individually, they are not particularly useful because what we need is a circuit that can remember either a 1 or a 0, not just one of them. Intuitively, our next step is to attempt combining both circuits and observe the outcome. By default, the circuit looks like this. The value held by the circuit depends ultimately on this AND gate. In order to get an output of 1, we can set both inputs to 1, and since the output goes back to the OR gate, we can reset the first input back to 0 without changing the output, but not the second input because it goes directly to the AND gate. Let's add an inverter to the second input and see what happens. By default, the circuit looks like this now. With this arrangement, if we set the first input to 1, the output of the AND gate will indeed be 1, because this inverter ensures that the other input of the AND gate is 1, even though the second input of the circuit is 0. The output of the AND gate, directly connected to one of the inputs of the OR gate, ensures that setting the first input back to 0 will still retain the value of 1 in the output. Similarly, if we set the second input to 1 while keeping the first input at 0, the inverter will cause the AND gate to output 0. And once again, the output feeding back to the input of the OR gate will make the circuit maintain a value of 0. Because even if we set the second input back to 0, the AND gate needs its two inputs to be 1 in order to output 1. So it will retain a 0 in the output instead. In other words, this circuit can remember one bit of information. Whenever we need to determine the current value held in the circuit, all we need to do is read the value from this wire. And there we have it. We've successfully created memory. We can encapsulate this circuit within a box that we'll refer to as an AND/OR latch. The first input allows us to set the stored value to 1, while the second input allows us to reset the stored value back to 0. Unfortunately, with this setup, things get a little weird when we set both inputs to 1 at the same time. I encourage you to explore what happens when you attempt to do so. Short answer, it doesn't make sense to try to set the stored bit to 1 while simultaneously resetting it back to 0. If we desire a more intuitive mechanism, we require additional circuitry that enables us to specify which value we want to store using a single input. After all, a single wire can transmit either a 1 or a 0, right? Well, yes, but there's a complication.
How you doing today,
As soon as the input changes, the output value changes as well. So, it no longer fulfills the function of memory. Instead, it simply outputs the current input value. To address this issue, we introduce another input that we can activate whenever we wish to set the value being remembered. We'll name this new input as write enable. With the addition of a few extra logic gates, we can achieve a more useful behavior. When the write enable input is set to 0, the value in the data signal is completely ignored, and nothing will happen. However, when the write enable input is set to 1, the circuit will retain whatever value is being passed to the data input. In this example, 1. And the value will persist even if we set the inputs back to 0.
No, Death Ranger. I was like,
Later, if there comes a time when we need to overwrite the value stored in the circuit, all we have to do is activate the write enable signal while inputting the desired new value we wish to store. In this case, 0.
Wait, did you not hear anything until you came
As
up?
long as the transistors that make up this gate are connected to the current, the value will be remembered.
I haven't heard anything.
One more time, we can abstract this circuit into a component known as a gated latch. And before continuing, I just want to clarify that there are several other ways to create latches. What I'm showing you here is not the only way to create circuits capable of remembering information. A gated latch is capable of storing one bit of information. If its write enable input is set to 0, no action will occur. But if the write enable input is set to 1, it will retain whatever bit of information is passed through the data input.
Having to do this moderation thing myself, so it's like it is what it is. All right, I
With
got
just
one
a
of the
single
videos
bit of
I wanted to post
information,
up top.
we can represent basic data,
Actually, there are two
like
videos
1
I
or
posted
0,
up top. One
true
of
or
them,
false,
I
or
wanna
simple
go get from
distinctions like
YouTube.
black
I'll
or
probably
white,
get them
but that's
put
it,
into
nothing too
space.
sophisticated. If we aim to represent a
Yeah,
broader
so-
range of numbers or a larger
four
set of
posts,
colors, a single bit
one of
becomes
them
insufficient.
from Quantum
We'll discuss the
Magazine, and then
solution
the other
after a
three
quick
of
message
them
from Code
being,
Crafters.
a
If you
post
like
from
watching
the
content
Department
on
of,
this channel, I'm sure it's
Energy,
because you
the
love
Office of
understanding how
Science,
things work.
which is
If you've ever wondered how your favorite
parts of
tools
the
like
Department
Git,
of Energy.
Redis,
And,
Docker, DNS servers, and even databases like SQLite work internally, there's no better way to learn than to build all those tools by yourself. Code Crafters offers challenge-based courses that will guide you through crafting these tools step by step. And the best part is that you can choose the programming language you want to use. So you are not only learning about these tools, you are also improving your skills with the programming language of your choice. Remember, one of the best ways to become a better developer is by building projects. If you are interested and want to support me, you can sign up for Code Crafters and choose the plan that best suits you using the link in the description below.
Yeah, feel free. Anybody,
One
like
single
I said,
bit
in
of
the
information
audience,
is
if you
not
want
really
guys hit the
useful,
request to
but
come
we
up,
can
if you
use
guys have
multiple
any questions
latches
about
to expand the
anything to
range
speak
of
about in
values we can
space,
store.
or wanna just
For
talk about
example,
the topics
to
that I
store
have
one
posted
byte of
above,
information,
guys are
we can
more than
employ
welcome
8
to
latches
come
and
up.
combine all of their
I
write
posted
enable
two
inputs
videos in
into a
particular
single
of them.
input that we can use whenever we want to override all
some
of the
most
individual latches at the same
detailed,
time.
And
A collection of latches
extremely
interconnected in this
well,
way is known as a register.
explained
In this
informational
example,
videos
an 8-bit
about
register.
how today
If you've
we
seen
are
other videos on my
producing
channel,
microchips,
you've likely come across the
particularly
concept of registers.
CPUs.
In previous
And
episodes, I've discussed
the-
various types such
the
as general
detail and
purpose registers,
infrastructure of-
the instruction
of
register, the
how
address
much
register, and the
actual
stack
work
pointer.
goes into
Registers
making
are often
just a
likened to
single chip.
variables integrated directly into the hardware circuitry, which is a solid analogy, although somewhat
That's actually
abstract.
needed
Ultimately,
to be
they
able
all
to do
consist of
what
logic
we
gates
are
composed of
producing today.
transistors, interconnected
And
in a
so,
clever manner to retain
with
values.
that thought,
The primary challenge with registers is their demand for numerous wires. The quantity of latches within a register determines its length, which can vary. Registers come in different sizes. However, larger registers imply an increase in both inputs and outputs. For instance, achieving a 1 gigabyte storage capacity would require a big register with millions of wires for data inputs and outputs. If we want to remember bigger amounts of data, we need another solution.
Network systems,
Instead of arranging latches in a linear array, we'll organize them into a 4x4 matrix, totaling 16 latches.
The GPU.
Our task now is to establish a method for identifying each one. To accomplish this, we'll utilize 4 wires for columns and 4 for rows. By activating a single wire in both the column and row, we can pinpoint a unique latch in the matrix. If we think about it, this mirrors the process of locating addresses on a map, where streets and avenues are typically numbered. So we can say each latch in the matrix has an address. Next, we need special circuitry to activate these wires in the described way. Fortunately, we've previously explored decoders. A decoder, when given an input, activates only one of its outputs. For instance, inputting 00 activates output 0, inputting 01 activates output 1, and so forth. By employing one decoder for rows and one for columns, we can input an address to select a specific latch in the matrix. For example, inputting 0000 activates the first output of each decoder. Inputting 0001 activates the first output of the column decoder and the second output of the row decoder, thereby selecting a different latch in the matrix. Each latch possesses its unique address, which gives rise to the term memory address. Now that we can identify each latch in the matrix by its address, our next step is to devise a method for both reading and writing its value using the fewest wires possible. We can start by adding a few extra components to each latch, so we can use a single wire both as input and output. To do this, we create a new input to let us toggle between reading and writing to the latch. Activating the read-enable
Oh, that's
signal
right.
configures
That's
the
right.
data
Faster
line as an
than, like,
output.
the thoughts are
Now,
faster.
someone might ask in the
Well,
comments
see,
about the output signal feeding back
I
into
don't
the
know why
input
you
of the
would,
latch during
why you
reading.
would want that
This
either.
is not a problem since the
Because if your
write-enable
thoughts
signal
were
is
faster
inactive,
than light,
thus
you
disregarding
would
any
be
input.
perceiving time
When the read-enable
at
input
the
is
speed
off,
of light.
the transistor prevents the
And
signal from reaching the
so,
output,
essentially,
allowing the
you
data
wouldn't
line to
exist
serve as
in
an
our mind.
input.
At least you wouldn't
With
perceive
the data line
yourself as
functioning
well,
as an input, we can set the write-enable data to
from a thought
1,
perspective.
overriding the current value stored in the
I
latch.
don't know. Interesting.
All latches
implications.
within the matrix
Yeah,
can
but
be
yeah,
modified in this
like I said,
manner,
I don't really
having
think
the
there's any.
required number of data
I think
wires.
nano
Instead of
second
32
speed
wires,
times are
16
probably more
inputs
than
and
enough
16 outputs.
that'll
We only need 16
more than
wires that
suit
can be
the needs
toggled
of
using
any,
the write-enable and read-enable
computational ability
inputs.
that needs to be allocated
But
from
we can
brain
take this
to, say,
further.
computer interface.
By connecting the data lines of all
But
latches
even
to a single
millisecond
general
times
data
is
line,
probably
the write-enable
okay.
input of each latch to a single write-enable line, and the read-enable input of all latches to a single read-enable line, we can set the value of all latches in the matrix without employing 16 data input wires and 16 write-enable wires.
Experiment to
Making all the
gain the
latches
advantage
remember
over
the
the
same value
financial
is not the
markets.
behavior we
That
want,
would be
though.
awesome. Thank you.
We need
Let
each
me know when
latch
it's
to
developed.
remember its own value. Fortunately, we are almost there, because we already know how to use decoders
Well, I
to
guess
activate the
if you were
cables intersecting
perceiving
precisely where each
thoughts
latch resides.
at the speed
We
of
can use the
light,
trusty old AND gate to
or
make some
faster
clever
than the speed of light,
modifications
you
to ensure that
theoretically
the
could go
write
forwards and
enable and
backwards
read
in time.
enable signals only reach the intended latch specified in the address input. As soon as the
At least
address
you
input
could
changes,
perceive this,
the AND gate
right?
obstructs any passage
And
of input
so,
signals through this point.
yeah, I mean,
So,
you'd
in
be
this
able to
example,
guess
even though the data
until
input of the latch is set to
when
0,
what's going to
the
happen in
latch
the
will
game
retain the
before it
value
happens.
1 in its memory, because its write enable input is 0. When all of the latches are connected
Okay,
in the
and
same
so,
way, we get this.
I'll bring it back to more of a scientific
Beautiful,
question,
isn't it?
though, right?
Let's
So
see this circuit in
and
action.
I meant to say, sorry,
Setting the write enable input to 1
metaphysical
allows the signal to
while
traverse
it
the
being
matrix,
scientific.
yet it won't reach any
And so
specific
I
latch
think
due
this
to
is
the
an
AND gates blocking
interesting
its
thought
path.
when we think about people
For the signal to target a
who
particular latch, an address must be provided, prompting the
been
decoders
allocated
to
the
activate
titles
one wire
of
each for the
playing a
columns and
role
rows. The
of
sole
an
AND gate
oracle
producing an output of
or
1,
a
thereby enabling the signal to flow to the latch, is where the active
an
outputs
agent
of the
able to see
decoders
the future or the
intersect.
past,
That's why this
something
latch
relative
just
to
changed its
someone-
value
somebody
from
who
1 to
maybe
0,
speak to, like,
as
dead one,
dictated
how
by the value
you-
on the data
you know,
line,
you
now
find,
utilized as input.
individuals
To
who,
revert the value of
who
this
kind of
latch
say
back
that
to
they have those
1, we
capabilities out
simply
there.
maintain this
I think this is
configuration
an
while inputting 1 into
interesting-
the data line. If the address input
a moment
changes,
that
the output of the
gets
decoders
lost
will
and
change,
not taken
causing the
advantage of
activated
enough,
outputs to
and
intercept at
where
a different
I think
location.
there's some sort of
And the write enable signal will exclusively
informational-based
target that specific latch,
entanglement
thereby
possible
overwriting its value with the
the
data
states
passed
of
through the
the
data line.
actions that would be existing as
If we
as
intend to
would
read the
perceive them at
value
two
of a
different
specific latch,
places in
we supply
time,
an address and activate the read enable
not
signal.
necessarily
This will make the
space.
signal traverses the
So,
matrix, but
I
exclusively
think
targets
that,
the latch specified by the address, making the data line
when you
act
think
as an
about
output. And this is how
maybe
we read the
information
value
being
any
able to
specific latch in the
move
matrix
faster
is
than light
currently
itself,
remembering.
not necessarily
It's
something that we're
noteworthy that the
perceiving,
value
but-
of the latch being
or
read is
able to
propagated
observe,
throughout the matrix,
but
directly reaching the input of
the
all other
understanding that
latches.
there is this
Since none of the
metaphysical
latches in the
kind of
circuit
net
have their write enable
spider
input
web that,
activated,
if I
this
pull one
value
piece on the
remains
net over
disregarded,
here, it, of
so the
course,
value
affects
contained in
all
the
of
other
the rest
latches
of the
won't be overwritten.
portions of net
Okay, what you
which
see
the
here is
gravity,
actually an
right, would be
oversimplification.
something significant.
And even
maybe
so,
it
this is
doesn't
starting to
affect the
get too
net all the way to
complicated.
the right-hand
I might have gone
side,
too far this
the
time,
spider
so
web
let's
to the
abstract
right-hand
all of
side,
this.
but
With
it
the
affects
address
a
input,
region in
we
my,
can select any of the internal
vicinity or
latches.
field,
By using
that
the
I can
read enable
interact
signal,
with.
we make the data line output the current value of the selected latch. Conversely, if we use the write enable signal, we can override the value in the selected latch using the data line as input.
You still
Now,
there?
we are still dealing with single bits.
I'm still there.
You probably already know that the minimum data computers handle
I'm
are bytes.
hypnotized.
To store bytes instead of bits, we can
Okay.
use 8 matrices. All these matrices will share the same address input, allowing us to select
take it.
corresponding latches across the matrices using the same address. The read enable and write enable
McQuack,
inputs should
we had
also be
Quickles
shared,
come up
as we want to read or
beforehand,
write an entire
and
byte,
he left
not
before
just
we got to
individual
speak.
bits. Each matrix will have its own data line,
love
providing
for
access
him
to
to
any bit
expand
within the
on this.
byte. For example, to write a byte to memory, we input all the bits that make up the byte through the data lines, and then activate the write enable signal.
Department of Energy.
This action causes each bit of the byte to be stored in the corresponding latch at
reading
the
the post
specified
above?
address in each matrix.
I
The
always
byte is
do.
now stored in memory.
Yeah, I don't have any
Later,
more to bring
if we
on
want to
the
read that
tips
byte,
other than
we
what I
input the
said
address and
yesterday,
activate the read enable signal.
which was,
This causes the data
information that
lines
I
to
had
output the
gathered
value
from
of
a very
each
long
bit that
time
makes
ago.
up the byte at that
But,
address.
uh,
When we write programs,
it does
we don't need
amaze
to concern ourselves with the underlying electronic matrix etched into the hardware. Instead, We think of
these
bytes as
chips
sequences of bits stored
and what they're
contiguously.
capable of doing
Thus,
these days.
we
It's
abstract
just,
this
yeah,
further
again, blows
and
my mind.
conceptualize memory as a list
Aren't
of
they getting to the
bytes.
point now where
In this
it's like
abstraction,
beyond
addresses aren't
human
intersections in an unseen
capabilities to
matrix,
actually
but rather
produce
indices in this
themselves,
list of
isn't it?
bytes.
Aren't we doing
This
it
is
in
called
more of
random
a,
access memory, since we can
you
point
know,
to any random byte in the list by
biological,
providing its address.
kind of synthetic way?
To simplify things,
Using,
we can
you know,
define these
like
sets of
small
wires as a
nanobots to
bus.
kind of make these
The width
chips
of the
now,
address
rather
bus
than
determines
us
how
doing
many
it.
bytes we can handle. For example, with an 8-bit address bus,
Well, they're
using
definitely
2
getting done by
decoders each
automation and
capable of
robots.
controlling 16 different
Swarms of
outputs,
nanobots?
we can locate any of
That would be really cool,
256
but
bits within the
not
matrix.
publicly yet.
Generally, if the address bus
Exactly
has
my
n
point,
inputs,
right?
2 to the
That's
power of
like
n
how
bytes can be
fast
managed. For
things
instance,
are
a
progressing.
32-bit wide
And
address
yes,
bus can address 4 billion bytes,
even
which
the
explains why
study
32 bits
of
computers
what's
can only
going on
handle up to
inside of
4
microchips,
gigabytes
right?
of RAM.
This being
Finally, keep in mind that the
mathematical
type of memory we have learned about today
equations
is known as static
that we can
RAM.
use based on
This
the
type of memory is
symmetries
very
of what
fast,
we're able
but
to
all these
measure
logic
occurring
gates
inside
require
of the
quite a few
microchip.
transistors,
And of
so
course,
the production cost is higher.
these
It
measurements
turns out that
being
those small
on
memory
that
cells in the matrix
nanoscale
can
level,
also be achieved using a
you
single
need
special
things
transistor,
like
called a MOSFET,
generative
and a
AI
capacitor.
models that
It
can
is cheaper to
build
produce,
these
but it is slower
mathematical
than static
symmetries
RAM. I'll make a
into
video comparing these kinds of memory.
simulations. And after
And that
running
about
these
wraps it up for now.
simulations and
In the next
feeding it
episode, we will interconnect all the
representative
components
data
we've
based
learned
off of
about
our
in this and
real-world
previous
environment,
episodes. This will help us understand how instructions like load, move, and store work at the hardware level to make data flow between components.
Architecture
So make
that
sure
is
to
beyond the
subscribe because you
grasp
don't want to miss
of
it.
even us
And if you enjoyed this
today,
video or learned
possibly
something,
understanding
hit that
what would
like
be
button. It's free,
graspable
and that would help me a lot.
5 days from now,
See you
10
in the
days
next
from now,
one.
3 months from now. And so, yeah, the significance of how fast those capabilities grow are with magnitudes. And so I posted something up top, X100 CP. It could be taken probably a lot of different ways. But what I mean by it is computational ability, 100x, right? In our lifetimes, I think we see easily. And that being conventional computation, of course, I'm not necessarily talking about quantum computation, but it being a very significant part of helping with the building of the graph models that could then be put into simulations. Quantum computer wouldn't be doing the simulations. That would probably be more conventional computational systems that would do that. However, the conventional computational system could utilize the mathematical probabilities that are answered from a quantum computer to build the most accurate simulations in our models that we use to forecast these microchips and technologies that we're slowly building. Don't let me do all the talking today, guys, though.
I want to just say because it just popped up on my timeline. It's a little bit not completely unrelated, but you put in Gen AI, so somewhat. So there's like beef with Elon and Google or something going on right now. Like he's declaring war. Like what is going on? Is this like an AI war? Are we seeing an AI war? That's wondering.
So, really interesting stuff, actually. And they recently filed a very large lawsuit, and they're having companies actually join them. And so what happened is this GARM consumer report came out, which actually by Congress, which showed a clear boycott monopoly happening with larger companies that were associating themselves and working together with other larger companies to boycott the ads on X. And so this goes against what is the act, the RICO Act in the United States. And so he's of course in his own way, social media wise, he's declaring war. But yeah, they're suing them. There are a couple large conglomerates, Mars being one of them, Google being part of that association. There's quite a lot of companies that are part of that association. Disney, is another one.
Yeah, because it's
Wax
interesting.
favorite.
But it's
Okay.
not as funny though as the Venezuelan president one, right? That really gives me a giggle when I watch him. I don't know if you guys have seen the videos, but the Venezuelan
What do you mean
president,
with giggle?
which
Like what is funny?
yes, very funny. So
No, no. What is funny about the Venezuelan?
so he essentially came out and had threatened Musk a couple of weeks ago, had basically said we're not scared of you in the United States military and your technologies and your space lasers. And so Elon Musk's response was, well, I have space lasers. So it was quite hilarious, actually, from the commentary that was taken back and forth. And then, of course, the Venezuelan president took it to the next step, and he said, come and fight me, come and fist fight me, and Elon, of course, had some pleasantry commentary that he put on X. So it was just an interesting back and forth. You didn't see all that?
I actually did. I actually did not. I mean, he comments so often sometimes, and yeah.
He does. He posts a lot. Yeah.
But by the way, I mean that is something else. But yeah, political stuff is also going through the roof currently. As always.
Yeah, I mean, it's big in the United States because we have elections coming up very, very soon, and of course,
Eric Trump just posted, I have truly fallen in love with crypto and DeFi. Stay tuned for a big announcement. This is so bad. Like, we have now political people making the classic crypto thing. Big announcement coming. I love it. I don't know if I love it, but I think I do.
yeah, no, it's really interesting. And Trump has been on like famous YouTuber channels, and he's hitting all the nooks and the crannies, right? It's really, really interesting, actually, to see how the difference in. I don't really even know what the other party is actually doing. So, but the difference in structures that we've seen possibly previously from years beforehand. Yeah, yeah, and I think the crypto thing is a really interesting approach. I think we're going to also see it flip on the other side because they're trying to get those voters, of course. Um, yeah, I think it was really perfectly timed.
Can I just ask Vet, can I ask you a question to the side quickly?
Yeah.
The XRPLF renaming. I'm literally like 2 sips in my coffee, and I just saw that. What's that? What's going on there?
Yeah, so if you go to the so I made a post, I think, but you can I quoted him, Barath, member of the XRPL Foundation, also known as Elo Networks. He posted a website with an announcement regarding the XRPL Foundation, and the announcement is that the XRPL Foundation is renaming itself to INFTF, which stands for Inclusive Financial Technology Foundation. And the reason for this is, I'm basically just quoting here too, is very often there could be a solution that is completely out of what is expected from an organization known as the XRPL Foundation. In recognition of this, we are renaming ourselves. Because it's undeniable fact that XRP and the XRPL ledger are linked by name of the native asset. This implies that the community has always expected from the foundation and more from the foundation than what it was able to provide. So basically, it wants to not be this. I guess not with not having XRP in the name is not going to be the go-to place. Just like, oh, XRPL and then it's XRP Foundation. But it's going like further where you have now essentially a bigger vision of it because the ecosystem grew. Think of Zahao, think of maybe even EVM sidechain and all of this, and they have different names, right? And if you call XRP Foundation, then maybe people think, oh, okay, XRP Foundation has nothing to do or is not supporting Zahao, which is not the case, right? Because they are supporting Zahao. So you need a bit more maybe neutral name. So this is why. And in addition to this, they follow up. There's now an opportunity for various stakeholders, such as primary maintainers of the ledger, like protocol engineers from Ripple and other people, but as well as validators, node operators, community-driven organizations, and even a DAO to come together to maintain the things that the foundation is currently a custodian of. So the XRPL Foundation currently is a custodian of various assets and IP, so to speak, namely the trademark of XRP. So the XRP trademark is held by the XRP Foundation. The code repository, of course, RippleD and other code contributions on GitHub, as well as the very famous and known xrpl.org domain, where you can find education and documentation for developers, but also users. So these assets and IPs, domains, code, um, is maintained and held basically as a custodian by the foundation. And with this new rebranding and or renaming, better said, they also want to do, according to this, involve more parties in this organization to together custody those assets. So it's not only going to be a few members, but it seems like, as it says, maintainers of the protocol, network participants, validators, community people, DAOs eventually when they come up to support this. These things must be done in an organized and non-partisan manner. So it's going to take time. Until then, it would be an honor to continue being custodian. So basically, this transition and of course structure, because we have no details or first drafts of it that we can chime in on and discuss, but they will come out, and everything needs time. But until then, for people to not speculate, I guess, and say what's happening in the meantime. In the meantime, just a normal XRPO Foundation is continuing what they're doing, and being the only custodian of it. But they, of course, as I said, are hinting that they want more people to be part of the of this organization, or however that's going to look like. As one of the publishers of the UNL, we would also ensure that we would continue doing so as long as it is deemed necessary. So until we get more details and I guess execute on it. We cherish the faith that has been placed in us thus far, and hope that you continue to cheer us on as we continue down our rather difficult path. Of course, it's very, very difficult at such an organization to navigate multiple ecosystems, as well as keeping track of everything that's going on. Like whoever is in the community, you know how difficult it is. Now imagine multiple ecosystems, Zahao, XRPL, EVM sidechain, whatever comes up in the future, and all these different community segments that you have as well. So it's very difficult, and they're asking us to support as well with our knowledge and expertise. So please do look forward to hearing more from us. You can follow us on X. There's a new website, a new account on X. You can follow that too. I have linked. I have tagged this in my post too. So please follow. All updates from the foundation will continue come from there. So if you want to keep up on updates, you have to follow this one. There, it seems not to be posted on the old one account, and our website will be functional in the next week or two. So more information are coming, and it's being put out. I think it's a really good timing that they put out, because there's been like a lot of confusion and also misconceptions. Maybe where is the journey? Like nobody had a clue what's going on, and so it's good that they put out, even though it's so early. You can tell that it's just this piece of text here on the website, but at least we know now where this is going, and I think it's going in a positive direction. It's not a bad direction, but it will need time. So that's basically it.
I kind of like the INFTF. It's got a nice kind of big boy ring to it, I guess. But so I mean, I guess anything you ask from here on out is kind of going to be speculation. But would this have anything to do as a result of that kind of restructuring, or that governance proposal that was kind of brought forward? I think somewhere at the start of the year, there was a GitHub proposal. I'm trying to find it. I can't find it. Of kind of restructuring.
I know what you mean. Yeah.
Is that a lead on of anything that had to do with that, or?
It could be. It could be also not. I I don't know if that would be only that. I would think it would be more XRP Ledger only focused. For me, this sounds more like the foundation itself, because it seems they want to include more ecosystems, primarily probably as a how, being agnostic to the whole ecosystem, which wouldn't make which makes sense for them right now in their situation. But I mean, you're right. It is definitely themed with this membership. If it's gonna be a membership, I don't know, honestly. But they are inviting basically people, so I'm curious how the structure is gonna look like. Um, so yeah,
I'm glad that you brought that up, actually, Dazzling, because when you think about it, right? When I was thinking about the XRP Ledger Foundation and their significance and position, well, if this was something that was talked about or told, say, to an organization beforehand, saying, "Oh, we're going to go this direction," I probably would have tried to put out the same type of proposal as just as you brought up that, right? I mean, them being someone who holds the trademark for the XRP logo and the keys or uh, uh, spots that
the
they hold
GitHub.
on the GitHub. These are some when I would think of something that would be significantly represented and part of the XRP community would have at least something in there, signifying it. That switch really makes me think in my mind that, from a community perspective, hopefully we're now incentivized as a community to really go out and try and do something where there could be an organization maybe represented as somewhat of a DAO. I definitely don't think it's as easy as they're kind of thinking it might be, because from an NPO standard, you're talking internationally, and there's a whole bunch of different rules and things that have to be applied when taking that into consideration. What happens to the trademark?
Yeah, the only thing I want to note here, I think this is very important, is um, keep your I think we should all keep our expectations low, because expectations can lead to pressure, right? Where then it might feel like a lot, especially in sort of transition and drafting phase and things like putting stuff out and hearing already maybe community members demanding and all of this. It is already tough to navigate the ecosystem, and very tough probably for themselves to um, get into this role and having this. If you are a member of the XRP Foundation and you want, or you recognize that you want to include more people to support your efforts as a foundation, you have a lot of efforts that you are trying to exercise on, then it is tough, right? It is tough. It's tough on a lot of parts, as you mentioned, even the legal part, but structuring, and everything that's around it. You do things now differently. So I just want to encourage everyone to just be, yeah, I guess a little bit more kind here with this. It's like very raw, and because it is very raw, it is also quite vulnerable for any sort of noise and all this. So we should let them cook, basically, let people say, right? Like, let them finish, let them get something solid out, and then we can, put out our suggestions. The only thing I would not love to see is people already just with this couple of lines of text, assuming things, or having expectations, or this is going to happen, they are going to do this and that, because yeah, it would be unfair also to them, just out of respect, I think.
I can see a lot of influencers going to town on this type of stuff with all the
Yeah.
speculative hype that they can bring to it. So yeah, no, I definitely 100% agree with you. But yeah, I think they've been a little bit quiet, of late, and some people, a while ago were kind of asking, well, what is going on, with the XRPLF? So at least it's good to see that there is kind of, wheels in motion behind the scenes. So yeah, that's kind of good. But sorry, Danny's got his hand up and been taking up a bit of time. Sorry.
Yeah, I agree. Thank you, Danny, for coming, man. Welcome up. Please feel free to jump in.
Oh no, that's okay. It's just a different topic. You guys can still keep on going. There's no worries.
Oh no, bring us back, man. Bring us back. If you're going to talk on the computation and photonics stuff I was speaking on before, or the videos above, please feel free.
Well, it's more focused based on Gen AI on Web3. I've been observing it, so it's all actually well, it's starting to be kind of focused on decentralized content creation, obviously, i.e., NFTs, security, enhancing security and decentralizations. I hope in the future, later on, a certain algorithm can process or predict already rugging, certain rugs and everything else like that. So that would help a lot. Anything via dApps, centralized applications. So on creations of certain, let's say, softwares, gaming, and all that. And I don't know if anybody has any, let's say, opinions or beliefs or understanding of like what could be further, because I can understand it can go beyond certain utilities that we can use for it, even in a financial kind of aspect too.
Oh, that was a lot. I didn't really plan on talking too much about DLT particularly today. I can definitely host it for another day, and we can go into depth on the encryption and NFTs and um, a lot of the information on blockchains and stuff. So I have no issue. I have no issue with that. Um, one thing that you did say that it was at the top of my head, but I've I've lost it now. So I'm sorry about that. Let me think. Uh,
That's all good.
oh, brain. Yeah, I lost my train of thought there. Sorry. Well, all right. If there was a particular question you had, then you're more than
Well,
welcome to.
on XRP smart contracts, how is there any certain limitations that you can not do? Or sorry, what would be
Oh
the
yeah,
limitation?
it's super easy of a question to answer. There are no smart contracts on the XRP ledger.
Oh, okay.
Yeah, so everything is, or you could think of the XRP ledger as I like this example. Think of the XRP ledger as just one big smart contract, right? It's just one large contract. The thing is if you want to make any changes that that change the way that the structure of the network would operate, the tools and actions that could be done, there needs to be a vote that gets taken and agreed upon for those changes to become done.
And later on, would it be embedded on your private key or something, or
No,
would it be
well, you're talking
global?
about network changes. So your keys
Oh,
should, and no matter what network it really would be, if there are changes to the network, there should be nothing done that would be associated with changes to your key, unless it was an encryption standard that was, say, changed and upgraded. Your key may just get longer at that point in time, or depending on the
what
way it's stored on the network. Of course, there's different methods.
would be the use case of Evernote and I forgot the other names. Because there's a code base or code language, right, in XRP?
Are you talking about Zaha?
Yes. I don't even remember the name. Oh, could it be?
Yeah, I mean, it was very close when it first started in as a direct copy of the XRP Ledger code base with some minor changes to it and the addition of hooks, which is a very light smart contract logic flow that's able to be done from an account based standard on the Zaha network. Evernode, something completely different. It's a different network altogether. It's actually a set of nodes of hosts that act as each of themselves as a network, if you want to look at it that way. And so it's a Linux virtual environment. Any code that could run on a Linux processing unit would be able to, be an application that could be run on a host. And then, of course, with that host being um, something that's able to be easily interconnected with other operations and applications, you could make a decentralized application very easily with it. A few clicks of the button, of course, as long as your applications are kind of written. Now, the one thing between Zahao and Evernode was that the Evers tokens exist on Zahao. And so if you want to use Evernode, you have to pay the host in the currency of Evers. And the only way to get Evers is obviously to have them on the Zahao network. There is an IOU for them, of course, I think on the XRP ledger, but I don't, you probably wouldn't be paying your host in an IOU of the EVR. At least I haven't seen any hosts accept something like that.
I see. And I'm probably a little lost. X100CP. Is it a chemical
Yes.
compound? No, I'm kidding.
No, going back to, and it's cool that you brought it up. That's why I put it in there so people will ask. So going back to what I was speaking about earlier about microchips and photonics and computational capabilities. And so I posted a couple videos up top. The last two videos past Vet's post, how do video game graphics work and how are microchips made, particularly CPUs, goes into a very detailed format of not only the making and the architecture of the way that transistors are laid and microchips are put together, but also went into a little bit of how GPUs are actually mathematically using the bits to create the architecture, which is that code base, right? That is able to create that imagery at such high standards at this point in time today. I mean, you have video cards that are able to produce things that are running 8K, so very impressive. Yeah, so X100CP is my belief, and of course I should say caveat that with the time frame of about 10 to 20 years, right? In our lifetimes, as I like to say, 10 or 20 years, as long as everyone expects to be around that long. I hope everyone in the space expects to be around that long, because I think if you do, you'll probably be able to have the capabilities of being around way longer. And that being said, life is what it is, so whatever happens, happens. X100CP is the belief of computational capabilities being 100x what they are today in the next 10 to 20 years, so in our lifetimes. And when I speak to that in a conventional flow way, and so conventional computation as we have it today, not necessarily quantum computation. Of course, quantum computation is millions-fold what we have in conventional computation today. Just quantum computers are very strictly task-driven machines. So it's not like things like we can build a simulation on a quantum computer. We can use a quantum computer to do mathematical probabilities in the form of linear oh my gosh, linear algebra, right? Which can break down the probabilities and feed a conventional system the most highly likely probabilities mathematically that would be able to occur in a certain scenario of actions. And so this is, I use the example NVIDIA. I'm going to stop talking today. NVIDIA earlier, with the way that they have increased their ability to have a diagnostic ray tracing that the chip is doing itself to further the production of the high-end standards of the video graphics that you're receiving on your computer or screen. And one of the ways they've done that is they've broken the chip down into a simulated environment, right, using things like generative AI models to build these model types that are then able to be graphed, and then you can use things like quantum computation to take all the mathematical probabilities and symmetries and create the most probabilistic beneficial outcome for you, and then put that back into a simulation, run it, you get great results. You have the highest probabilities of producing an actionable state that you mean to have represented in our reality, be in the form of a microchip. And so we are increasing the understanding of photonics, which is the study of the array of light, the understanding of the electricity that is flowing through the transistors and the magnetic fields that each of these transistors create themselves through these interactions, and furthering the ability for us to have just this computational capabilities.
That's a lot of information, man.
I tried to sum up like the last 30 minutes, and I think two.
Awesome.
definitely was a lot. But there's these two videos that I posted up top. How are microchips made, and how do video game graphics work? And of course, they're a little bit longer than the space has gone on for so far, but both, I mean, just highly detailed, information structured videos.
Is there any difference between a 2.5 3D kind of aspect, or they're all similar as gaming?
For gaming wise, well, I mean, I guess that would be more of a point of view, from the characteristic of the visual representation you enjoy. Like arcade games are way more kind of like 2D based on the screen, where you have very in depth games today. Um, take something like a Call of Duty, where you're in an environment that has multiple image layers on top of itself, and so you could kind of get this, as much as you are viewing two dimensions, you get the feeling of three-dimensional space. So I guess it's really just a point of view on what you kind of like to have. Something that was brought up yesterday, though, from Shellfish, right? She had asked, actually, she was like, well, don't we kind of see in four dimensions? And, you know, it's like funny because we kind of say we're in the third dimension, but we have this 3+1, right? That we see three dimensions, but plus time being the fourth dimension in some sense. Um, but a fourth dimensional object being something that's just kind of like wacky to the brain, because I don't know if you can think of a fourth dimensional object, but I don't think I can, at least not in a meaningful way.
3 dimensional would probably be your environment, and air quote time would include the extra. So let's say, for example, you have Call of Duty, so you're in the sandbox, so that's the environment itself, and then you have your character that's in the environment, and just yeah.
Yeah. The thing is though is of course, you being the character, you don't perceive the environment, you perceive you being the environment. But yeah, it's kind of like this
or
absurd.
interact or interacting in the environment.
Yeah, well, even then, right? Like, even the interactions of what you would say to be your environment is really an interaction with you and your environment. Because if the photons from the environment, which we think of makes up all of the signals of reality that you're viewing, right? The visible light spectrum, being an interaction of interactions of interactions of interactions of particles of photons that then bounce around your eyes, which then get read and put together as an imagery. It is essentially still you interacting with the environment. Yeah, I thought.
And as you as a separate avatar in a certain way.
Yeah, and see, that's the fourth. That's possibly what you would think of as like a fourth dimensional perspective. Is the viewership of the avatar itself, and so from that perspective, you can kind of see like the beginning and the end. You can kind of see what's going to happen and not going to happen. Of course, if you get to that kind of perspective field, I think, of course, we're not able to get to that physically, maybe perhaps conceptually, but I think mathematically, I think that's a lot of the symmetries and understanding the things like platonic solids and platonic space. I think that's gonna, yeah, definitely come into place when we look at it from a dimensional perspective rather than just a singular third dimension perspective of space and time.
I, I would agree, because it's another set of, let's say, language or everything else like that to implement or understand said laws.
Yeah, exactly. Set of different fundamental laws that could possibly exist in such a different perspective of standard. And what would a different perspective of standard even mean in interaction with our particular perspective of standard? Is there even an interaction that is a meaningful way? Because, like, are there interactions from a fourth dimensional perspective that are happening in our third dimension right now? How would we know? How would we perceive that? So yeah, interesting questions. Dayton, though, you haven't gotten a chance to speak yet, man. I'm probably gonna close up in the next 10 minutes or so. So
Cool. Yeah, no, no, I was just enjoying the conversation and doing a bit of work as well. So it's always kind of nice to kind of drift into parts that I feel like I can contribute to also while trying to learn something new. But yeah, also trying to get some work done here. But I liked your post, kind of giving a little bit of the primer on how video game graphics work. I just got my Xbox X series in, and going to be setting that up. I'm getting back into gaming, probably to my detriment a little bit, but my daughter, my youngest, she's a gamer as well, like hardcore. This kid's built like whole worlds in Minecraft, and she does all kinds of stuff like that. Her brain thinks at some pretty extraordinary speeds, and she's got a pretty fast click rate from what I can tell. We go like to the retro gaming places here, in town, and I introduced her to like a lot of the games that I grew up with. But Xbox is going to be a good platform, I think, apart from like her computer and her cell phone. Kind of a dedicated thing. She's had the Wii, and she's had a couple of other platforms that have been, I think, decent. I'm kind of curious to see what Xbox is doing in terms of augmented or virtual reality. I'm not totally on board necessarily with getting like the Apple goggles, or whatever it is they're categorizing them as. So yeah, we're going to start there, and then I'm probably going to build a gaming platform of my own, just because there are just some things on Xbox that aren't available. But I'm looking forward to getting back into like Splinter Cell, like retro stealth games, all that stuff. I love those games. I like really anything to do with flying. Some first-person shooters are okay, and I'm also interested to see what's new on offer. What's been published since I had my last console. So we'll see what that offers as well. I'm not entirely sure how I feel about this subscription-based model, but if it gives you access to everything, I kind of like owning my own games, my owning movies and things that I purchase on that platform, to have it and take with me. And I don't really want them kind of pulling an Apple, I guess, is my take on that. But yeah, looking forward to getting back into gaming, and so I'll peruse through that content you put up there, and see how it's built out, because I think the animation side of things has just come so far, but it's also cool that you can go back and run older games, at that aspect ratio, and yeah, kind of go down memory lane. I want to get my kid into like a GoldenEye matchup or something like that, and see how she does in that realm. So, but yeah, she's a good shot though, at least in the games. We'll see what happens. But yeah, fun conversation.
No, and thank you for coming, Dayton, and just being here adds in. So I really appreciate it, and I wish you lots of fun playing video games, man. It's a great saying. I've heard a lot of people, especially older people, sometimes kind of articulate this. I can't hang out with my children anymore because they're always busy on the video games, and they don't spend any time with me because they're on the video games. And there's this this thought that I've seen as a post beforehand, where it was, don't expect that everyone's going to always meet you at your level, right? If it's time that you want to spend, in this particular case with your daughter, meet them at their level. And so video games being this like perfect place to meet level wise, because everyone has fun playing video games, so you actually sit down to play the video game. So I couldn't agree more with it as a thought of bonding.
And it works with my youngest one, because my oldest, there's 5 years between the two of them. My oldest is not a gamer at all, so that's not a path to spending time with her. I had to figure out other things with my older one. But for right now, gaming works with the 15-year-old, so I'll take it, that swimming and outdoor stuff, definitely, and she's learning driving here pretty soon. So it's going to be a fun year. Looking forward to it.
It's awesome. But the graphics, yeah, the video I posted up top, if you're into looking at that aspect ratio, which I love that you use the terminology for, um, how they count the pixel count and the dimensions on the screen. I think it's gonna blow your mind. At least it blew my mind somewhat, because it showed all of the steps of the architecture, all the way from the transistors that are acting as somewhat on and off switches with electrical current going through them, breaking it down into the bits, and then the actual architecture of the way that those bits are calculated in different steps processes that then leads to what we would have produced would be our graphics on the computer screen. So yeah, I thought it was just a really, really excellent breakdown. Of course, I think the other video I posted beforehand, the CPU video, maybe leads into it also. There's a video I wanted to post, but I didn't get a chance to before I hosted the space. I'm going to post it a little bit later today. It's on schedule already, where it actually very in-depthly breaks down the transistors. So actually how transistors are able to calculate bits, ones and zeros, through the electrical currents that are being distributed through the system, and how that plays into the microchip, of course, that uses a syntax, which is just a computer language to interact with those bits and have some sort of occurrence occur and or place occurrences on. So yeah, I think it's so in-depthly insane when you really think about the tools and technology and how it actually is doing the interactions it's doing and having the outcomes that it does, and of course in our everyday life, us being on the phone right now and having this pretty much instantaneous way to relay information with each other that is in the form of bits. Of course, you and I are not hearing
Right.
bits, but
Right. I
go ahead.
agree, because it's and the more tactile feedback that gets built into it. So say almost like that Ready Player One kind of suit, where you're dropping into a game or you're dropping into a simulation, or law enforcement, they're running, simulations on a raid they're going to do, for a hostage rescue, or that applies to military applications as well. You're rehearsing a hunt. There's you're rehearsing, playing in front of 100 people, on a type of musical instrument, or you're rendering AI in real time, either through thought or by your own hand, but it's all getting fed in at this higher and higher rate. And with clearer and clearer passes of imagery and clearer and clearer scientific um, resolution, to all of these things that we're seeing. And we're talking about 8K now. I'm still trying to wrap my coconut around 4K. With things that got 8K now, imagine when that's streaming into your head, and you're playing a movie in your head while you're doing work, or rocking the baby to sleep, or whatever. It's an interesting world that we're going to see be built out in the next generation or two. And I think the longer we live, kind of getting back to what you were saying, being just slightly longer lived than what the average human has been. I don't want to live forever. I don't think that we should. But I think the longer we're around and contribute, the better, and that includes pumping out some badass video games, because video games, I think, for a lot of people, are teachers as well. you know Kids, certain kids, not in every instance, of course, but with certain kids, it works for their brain, and it helps them adapt, and it helps them run calculations on how they're going to interact with the world itself, and it's a stress reliever for them too. So and I'm very far removed from the whole, oh my God, they're teaching you demonic stuff, and playing Ozzy Osbourne backwards while, on the video game track and all this other stuff. I don't really buy into it, particularly from the violent side of things. That's been around in movies, that's been around in film, that's been around in play acting, going back since they've had play acting. So, and I don't think it really has a direct impact on whether or not a person might be prone to a violent act. I think people who are tend to come to that sad junction in their life, through other ways, and usually it's just a loss of control, of themselves. So you should be able to play a video game and not, have some kind of Category 5 meltdown. And if you can't, then I think that professional help should probably ensue. So, but that's just kind of my take on it. But yeah, I'm here for the video games, and I'll let you guys know how the Xbox goes.
Thank you. I was just about to say, you got to let us know how it goes, and I couldn't agree more. It's a complete lack of control when someone makes an action in such a regard, and typically, I think those actions are associated with a direct self-esteem issue that's usually held by the individual. So, yeah. But I like to say also, your daughter is and many others. The children are the architects of the future, and the future being much involved in the digital landscape of our species. Yeah, very, very important. But this has been a great conversation today. I truly appreciate everyone who came and shared information. Dayton and Danny and Bet for coming up. McQuack, thank you for coming up earlier. It was a fun conversation. And for anybody who hasn't gotten the chance yet, if you guys want to open up those videos up top, how microchips are made and how do video game graphics work. Really great informational videos going to the high depth details on the particularly talking about how CPU chips are layered and made, all the different techniques and machines that are used in such a action, and how detailed, how gritty video game graphics operate inside of your GPU, how the calculations of those bits turn into the high-end resolutions that we see on our screens. But anyway, I don't think I will have the space this Thursday, 4 p.m. Eastern Standard Time. If I do, I will post something about it on Thursday. But we'll be back Monday next week, 4 p.m. Eastern Standard Time. So I hope to see everyone then for sure. Love you guys, and I hope everyone has a great rest of the night. Night, everyone.
Good night.